Okay, so we're still working with our fundamental identities and our trig function definitions. Let's solve the system of equations given as 5 cosine of x plus 25 sine of x equals 23 and 30 cosine of x plus 5 sine of x equals 22 to find the exact numeric value of secant of x and of tangent of x. Now at first glance, most students look at this and think, oh no, what in the world is that? I'd like to try to make it easier for you. Let's let capital C represent the cosine of x, and let's let capital S represent the function sine of x. Then take another look at how these equations present. You'd have 5c plus 25s equals 23. And you'd also have 30c plus 5s equals 22. We have two variables and two equations, and this is what I would call a 2 by 2 system of equations. So if we can solve for both the values of capital C and capital S, then we'll have the values of cosine of x and sine of x. And from our definitions, we know that secant of x is the reciprocal of cosine, and tangent of x is the value of sine divided by the value of cosine. So it seems that if we can get the values of sine and cosine, then we just substitute them into our definitions and identities, and we're good to go. Alright, so now you have a couple of options here. You can solve this system purely by substitution, which means solve for one variable in one equation and substitute it into the other, solve again and back substitute. Or you can use a process called elimination. You may take your pick, but I personally think elimination may be a little cleaner in this case. And elimination works in this way. Let's say I want to eliminate the variable s. Then I would need this term in the second equation to be negative 25s so that it would cancel with the 25s in the first equation. So that means I'm going to multiply by my second equation by negative 5. And that would produce negative 150c minus 25s equals negative 110, while my top equation stays the same as it was. Okay, so let's add these two equations together. And here we would have minus 145 times c plus 0 equals negative 87. And we can finish solving for c by dividing both sides by negative 145 and have 87 divided by 145, which you actually don't have to reduce, but if you did reduce, it would reduce to 3/5. But it would certainly be okay to use the cosine value in this realm if you didn't want to reduce. Okay, now let's go back and rewrite the system and repeat the process from the original system, and let's eliminate c this time. Okay, or if you wish, you can take the value of c, substitute into one of these two equations, and solve algebraically for s. So you can use elimination and substitution in context together. It's totally up to you, but I'm going to do elimination again just to demonstrate the process. Alright, well this time I see that to cancel c, I would need the 5c and the 30c to have the same coefficient, And 5 times 6 is 30, so I'm going to leave the bottom equation alone. And I'm going to now multiply my top equation by negative 6, which would give me negative 30c minus negative 150s equals negative 138. Now let's do as we did before. Let's combine these equations. We would have 0 minus 145s equals negative 116. So the value of s is positive 116 divided by 145, which is perfectly fine as an answer, or you could reduce to obtain a reduced value of 4/5. But again, this is sufficient, or you can use this guy. Now, since I went to the trouble to reduce, I'll use those. But again, let's go back. We're saying that the value of cosine of x is 3/5, and the value of sine of x is 4/5. Okay, and we're going to use those to get our answers. Okay, let's go up here. So if secant's the reciprocal of cosine, then if cosine's 3/5, secant must be 5/3. If tangent is sine divided by cosine, then you have the value 4/5 divided by the value 3/5, which reduces to the value 4/3. Okay, and that's how we solve a system of equations completely by elimination. You, however, again, could have used substitution entirely or a combination of elimination and substitution. All right, and one more side note. If you have time to check yourself, you should check, okay, the square of cosine plus the square of sine, our identities say that should be 1. So if 3/5 squared plus 4/5 squared didn't equal 1, we would have made an algebra mistake somewhere. Okay, so we do the calculation, and notice, thankfully, that we have done this correctly because it does check.